Okay, guys, today we're going to talk about simplifying numbers in radical signs, specifically square roots today. So we're going to start with something basic, like the square root of 75. And if I want to find the square root of 75, I can break it down into its prime factors. Okay, so if I look at 75, I know that breaks down into 25 times 3. Now, some of you may see right here, you can write it this way, 25, the square root of 25 times the square root of 3. And we know the square root of 25, so that would be 5. And the square root of 3 can't be simplified anymore. So you might know it that way, but I'm going to just show you right down to the wire in case you need to know a little bit more. So I could break this down. So let's get rid of this for a minute. I could break 25 down further into 5 times 5. So now it looks like this. Square root of 5 times 3. And if I look, what I'm going to try to do is I'm going to try to find, when I'm finding square root, I need 2 of something. If I have 2 of something, that means I can bring 1 out. So the square root, right, since I have 2 5s on the inside, I can bring 1 5 to the outside, and that cancels the 2 5s on the inside. If I look at the 3 in the square root sign, it has no partner. And since it has no partner, it stays in the square root sign, and I'm leaving it like that. And that's how I would simplify the square root of 75. Another example, different kind of example, is if we had, let's say, a fraction. So we might have the square root of 8 over 25, all in the square root sign. Now remember that we could rewrite this as the square root of 8 over the square root of 25. I know the square root of 25. It's a perfect square, and the answer to that is 5. The square root of 8, I'm going to break it down. So I'm going to break it down. You can break it down into 4 times 2. And then you can break the 4 into 2 times 2, and then bring that other 2 down. So I have 3 2's on top. So when I have 3 2's on top, I'm going to look to see if I have any partners. And since I do, since I have 2 2's in there that are partners, I can bring one of those 2's out. Sorry, let me do it a different color. I'm going to bring one of those 2's out, and that cancels 2 on the inside. 1 2 on the outside is worth 2 on the inside. And then you have the square root of 2 still left in there with no partner. That one stays inside. And your answer would be 2 the square root of 2 over 5. Pay close attention that the square root sign is not on the 5. That's just the whole number 5. Okay, that's how you would do that problem. If, for instance, there's a negative sign when you start, that means your answer is going to be a negative number. So just make sure you put that in. Okay, so let's talk about if there's a lot of letters in there, because those get a little bit more complicated. So let's say we have the square root sign, and inside it says 49 x squared y to the third power z, and I'm going to say a to the fourth power. All right, looks like a really complicated problem, but it's not that complicated. I like to separate them all into their separate square root signs. So the square root of 49 times the square root of x squared times the square root of y squared, oh no, y cubed, I'm sorry, times the square root of z times the square root of a to the fourth power. This way we can do each one separately and break it down. It's so much easier to do that, and you'll see that it's not that big of a deal. So we'll start with the square root of 49, and the square root of 49 means what number times itself gives me 49? It's just 7. So that gets rid of that. The square root of x squared can be broken down into x times x. And remember, if I have 2 of something, I can bring 1 to the outside. So since I have x times x, I'm going to bring 1 to the outside, and there's nothing left inside. So we just took care of that. Now, when we look to y to the third power, that means I'm multiplying y 3 times. So we're going to look. You can see that you have a partner group in there. You have 2 y's. You can bring one of the y's out, and that cancels 2 of the y's inside. Notice there's still a y inside. It's going to stay there. Now we look z. Since we only have one z there, okay, the square root of z, we only have one z. There's no partner. There's no way to simplify it. That z stays in the square root sign. So that's going to stay there. Now we have a to the fourth power. That means a times a times a times a. And so we look, and we're looking for groups of 2. So there's a group of 2. That means we can bring one A to the outside. So we'll bring an A here, and that takes care of those 2. Then I have another group of 2, means I bring another A to the outside, and that gets rid of those 2. Sorry, that looks a little messy. Let me fix this. It looks like this, and this is A times A. All right. So it still needs a little simplifying because I have A times A, and that can be simplified. A times A means A squared, right? Means A multiplied 2 times. That's what an exponent is. So our answer here is 7x y. A squared times the square root of y z. Seems like a complicated problem, but it's not too bad if you take them one step at a time. Okay, now we'll check one more time, one more example. Actually, I have a couple more examples to do. So let's take a look. We have 2 minus the square root of 125 over 4. All right, so this is a little different. This has an addition sign or a subtraction sign in it. So first thing you do is take care of the square root. So I'm going to break down the square root of 125. And if I look, I know that's 5 times 25, and the 25 can be broken down into 5 times 5. So it looks like this. Notice I have partner group of 2, so I can bring a 5 to the outside, cancel out 2 on the inside. This is a 5 left, so that's going to stay like this. So if I'm going to simplify this, all right, I just change that so it looks like this. 5 to the square root of 5 all over 4. Now, if I want to simplify this more, I have to check these 3 whole numbers, okay, and see if all those 3 numbers can be divided by the same thing. In this case, there isn't anything that 2, 5, and 4 all divide evenly by, so it stays the same. Important note, never, ever, ever simplify into a radical sign. That radical, that square root of 5, that stays as a square root of 5. You're never going to simplify it unless there's another number in the radical sign with it. But in this case, you're not going to do that. So let's do one more example. We have 2 plus the square root of 32 all over 4. So our first step is to take care of the square root of 32. And I know that breaks down into 16 times 2. Now I can see, because I know 16 is a perfect square, I could automatically take the 4 out. I could take the square root of 16, which is 4, and take that to the outside. Or I can continue to break it down to 8 times 2, bring down that 2, and then break the 8 down into 2 times 4, and bring down the 2's, and then 2 times 2 times 2 times 2 times 2. All right, so now we have this. This is the prime factors of 32. And so what I'm going to look for is any partner groups. So if I look, I have a partner group of 2. So I bring one out, cancel those 2. Another partner group, bring one out, cancel those 2. One's left inside. When you bring more than one number out, just remember that it is multiplication out here. You're going to multiply those 2. So this would actually be equal to 4, the square root of 2. So I'm going to rewrite this here. So now I have 2 plus 4, the square root of 2, all over 4. Oh, that's a weird looking sign. Okay. So 4 the square root of 2 over 4. Now, can we simplify? Again, what I'm going to be looking for is the 3 numbers outside of the radical sign. Can they all divide evenly into something? And they can, or evenly divide by something. And they can. I can divide them all by 2. Okay, so I'm going to divide this by 2, and that's going to give me 2. Divide this by 2, that'll give me 1. And divide this by 2, that'll give me 2. So I'm left with 1 plus 2, the square root of 2, all over 2. Notice I didn't simplify into the radical sign. The radical sign stayed just as it was. I'm not going to combine these. 1 plus 2, the square root of 2. That's like saying 1 plus 2x. You can only combine if they have the same square root. So, for instance, I could say the square root of 2 to the square root of 2 plus 3 to the square root of 2, that would, you can add them together. That's like saying 5 to the square root of 2. It's like 2x plus 3x because they have the same number inside the radical sign. So you can combine them. However, if I have this, and let's say I have 2 to the square root of 3, now that's like saying 2x plus 3y because these two are not the same. And if they're not the same, you can't combine them. And that goes for a general integer being added with something with a radical sign. You can't do that. So this would be the answer. There's nothing more you can do. You can't simplify it anymore, and you cannot add the 1 plus the 2 here. And that's it. That's how we would do simplifying radicals.